Class, in this video, we're going to be looking at summary statistics. The learning intention of this video is for us to learn how to calculate the summary statistics of a dataset by hand as well as by using the CAS calculator. The summary statistics is essentially a list or a summary of numerical information that describes both the central value and how dispersed and scattered the data values are. By knowing these key information, we are therefore able to make comparisons with other datasets and make conclusions. If I've got the summary statistics of a dataset, this means that I know the mean, the median, the mode, and in terms of the measures of spread, I could find out what is the range, the IQR, as well as the standard deviation. And in this particular lesson over here, we're going to learn how do we calculate all these by hand as well as using the CAS calculator. The first part of this lesson is for us to review how do we find out the mean, median, and mode. The mean of a dataset can be thought of as the balance point of a dataset. And symbolically, we use the letter X with a dash on top of it to represent the mean of a dataset. To find the mean, you may recall that this was done by finding the total for all the values within the dataset and then dividing it by the number of values that's contained within the dataset. I'm going to use the example on the right hand side to demonstrate the notion of the mean being a balance point of a dataset. So to illustrate this, what I'll do is I'm going to draw a block for each of these numbers found on the ruler. So if I've done this, this is what it will look like. As I've stated earlier on, we want to think of the mean as a balance point. So in this example, it's essentially the value where these blocks are balanced and doesn't cause the ruler to tip to one side at all. So if you calculate what the mean was, you're going to find that that's going to be equal to 2.5. As a result, we should place the pivot or the triangle under at 2.5 of the ruler, as this is the center of balance where the ruler and blocks will remain at the same level. And this is how I would like you to think what the mean represents for a dataset. Let's now look at another example to calculate the mean. So in this example, we want to find out what is the average number of cavities that are observed in the following patients. So the way that we do this is we find out what is the total sum of all the values found in the dataset, and we divide it by the numbers found within the dataset. So there are 7 values, so therefore I'm going to divide it by 7. If I put this into the calculator, 20 divided by 7 is going to equal to 2.86. So that's the average number of cavities that we observed for the following 7 patients. Another way for me to obtain the central value of a dataset is by finding the median, and this refers to the middle value of a dataset when it has been arranged from the smallest to largest. It is very important that we do this, otherwise it will be difficult for us to find out what is the median value correctly. I also want to note that when you're dealing with an even number dataset, the median value is obtained by adding the two middlemost numbers together and then dividing it by 2. Let's now look at an example down below that involves an odd number dataset. So in this dataset, it's really critical that we arrange it from the smallest to largest. So this is what our dataset now looks like. In this template over here, we can clearly see that the median value is going to be equal to 1. But another way that you could show this is by crossing out the numbers from either ends of a dataset and then progressively making your way to the center until you reach one value. And in this case, again, it's going to be 1. The next example involves an even number dataset. Similarly, we're going to need to sort the numbers from the smallest to largest. So therefore, your dataset should now look like this. To find out what is the middle or the median value, we need to cross out the numbers from both ends of the dataset and progressively make our way to the center. However, if you do this, you'll find that for an even number dataset, it is impossible to arrive to one value only. So therefore, we need to find out what is a number that's halfway in between the two middlemost numbers. To do this, we need to add those numbers together and divide them by 2. And in doing so, you're going to get an answer of 14. So that is the median value for this dataset over here. There's also another way for us to find out the median, and this is done so by finding out what is the median position. So the median position can be found by applying this formula over here. So I'm using the n plus 1 divided by 2, where n represents the number of values found within the dataset. I do want to make the distinction that the median position is not the same thing as the median value. When you've got an odd number dataset, the median will always be one of the values or one of the items within the dataset. However, when you've got an even number dataset, the median value will always be the value that's halfway in between the two middlemost numbers. Let me show you an example to demonstrate how you could find the median using this method. So in this example over here, the number of values in this dataset is 9. So if you go 9 plus 1, which is equal to 10, 10 divided by 2 is equal to 5. So what this is saying is that in the dataset, if I rearrange it from smallest to largest, which is already done so, the median value is located in the 5th position within the dataset. So in this example over here, the 5th number is going to be 15. So therefore, that's going to be the median value of this dataset. Let's look at one more example. So in this example over here, I've added an extra value. So in this example, you go 10 plus 1, which is going to equal to 11. 11 divided by 2 is going to be 5.5. So in this example over here, it's saying that the median value lies in between the positions 5 and 6 within the dataset. This means that the median value lies in between the numbers 15 and 18. So we just need to add those two numbers together and then half them. And if you do this, you're going to get an answer of 16.5. Now that we have reviewed how to calculate both the mean and median, let's now discuss which one of the two measures of center are more reliable. So we tend to use the median as a preferable measure of center, as this will give us a better typical value for most datasets. This is because, unlike the mean, the median is not affected by having outliers as well as having skewed distributions. So in this example over here, I've got a symmetrical dataset, and when you've got a symmetrical dataset, notice how the mean is identical to the median. Therefore, it doesn't matter whether you want to describe the center of the value by using the mean or the median, since both values are very similar to one another. However, when you've got a skewed dataset as shown over here, what this does is that the mean is effectively being pulled by all the values that's found in the longer tail. So as a result of this, the mean is therefore different from the median and therefore becomes more unreliable when you've got outliers in this case. This is also illustrated in this diagram over here. You can see that when you've got values that are abnormally small or abnormally large, this will effectively change the mean of a dataset and is therefore not a good indicator of the central value of a dataset. The next thing that I would like to talk about are the measures of spread. In the previous video, we talked about the spread tells us how dispersed or scattered the values are within the dataset, and that there are 3 indicators or ways that you could actually find the measure of spread. You could do this by finding the range, the interquartile range, or the standard deviation. However, for the purposes of this video, I'm not going to go through any examples as to how to calculate the range, because I think this is relatively straightforward, as all you need to do is find out what is the largest value and subtract it with the smallest value. So let's look at what is the interquartile range and how do we calculate it. The interquartile range, or IQR for short, is a measure of spread of the middle half of a dataset. The way that we calculate this is by finding the difference between the upper quartile and the lower quartile. Let me unpack what these following words over here mean so that you have a better understanding of what the IQR represents. So what I'm going to do first is I'm going to find out what is the middle or the median value of a dataset. So if you do this correctly, your median value is going to equal to 4.5. You can see that the median effectively divides the dataset into 2 equal halves. And what you could do is that you can find out what is the median within each of these respective halves. If you were to find out what is the median value of the lower half, that's going to be equal to 2.5. The median value of the lower half of a dataset is referred to as the lower quartile, which is denoted by the symbol Q1. So in this case, your lower quartile is equal to 2.5. If you're finding out what is the median value of the upper half, you're essentially finding out what is the upper quartile, and this is represented by Q3. So in this example, your upper quartile is equal to 6.5. And by finding out what is Q1 and Q3, this essentially tells us the middle half of the dataset. And this is going to be true since that we know that there are 8 values within the dataset. So therefore, the 4 values in the center are the middle half of a dataset. Now that we understand this, we can therefore calculate what is the IQR by finding the difference between Q3 and Q1. So therefore, I'm going to go 6.5 minus 2.5, and therefore my IQR is going to be equal to 4. So on this slide, I'm going to list down all the steps that are required for us to calculate the IQR of a dataset. So the first thing we do is we need to sort the numbers from the smallest to largest, and then we can find out what is the median. After we have done this, we need to divide the dataset into 2 equal halves, but I want to comment that when you've got an odd number dataset, we exclude the median from both halves, and you can see that clearly in this example on the right hand side. Notice that the median in this case is not included in any of the halves at all. However, when you've got an even number dataset, we do not exclude any values at all from the 2 halves. So this is represented on the example on the right. Because 4.5, which is the median, is not a value found within the actual dataset itself, therefore we need to include 4 in the lower half of the dataset and therefore 5 in the upper half of our dataset. After we have done this, then we could therefore calculate what is the Q1 or the lower quartile by finding the median of the lower half, whereas the upper quartile is found by finding the median of the upper half. Then we can find out what is the IQR once we've completed steps 4 and 5. So let's go through an example. In this example, I'm going to sort the numbers from smallest to largest, and now I'm going to calculate the median by crossing the numbers from both ends until I reach to one number. So if you have done this correctly, then you can see that the median value is going to equal to 72. And now, because this is an example of an odd number data set, we exclude the median from both halves. So therefore, we eliminated that value, you can say, and therefore that's going to be my lower half and that's going to be my upper half. To find out what is the lower quartile, I'm going to find out what is the middle value in this data set over here. So I can clearly see that the middle value between 64 and 64 is again going to be 64. So I'm going to write Q1 equals to 64. For the upper half, the upper quartile can be found by finding the median between these two values over here. So therefore 77 plus 81 divided by 2 is going to give you an answer of 79. Now that I've calculated Q3 and Q1, I can now calculate the IQR by going Q3 minus Q1, which is going to give you an answer of 15. Please have a go at trying to find out what is the interquartile range for this dataset. For this question, we could already see that the values have been rearranged from smallest to largest, so we can move on to step 2, which is to find out the median. The median can be found by crossing out the numbers from both ends until you reach a central value. So in this case over here, because you've got an even number dataset, you need to find out what is the value that's halfway between 6 and 7, which is pretty obvious in this case, which is going to be equal to 6.5. Once we have found out the median, this divides our dataset into two halves, and now I can find out what is the first quartile. So to do this, I'm going to find out what is the median of the lower half. So in this case, that's going to equal to 3. For the upper half, I can see that the third quartile is going to be equal to 11, and so therefore the IQR can be found by going 11 minus 3, which is going to equal to 8. The next thing that I'd like to talk about is the standard deviation. So the standard deviation, which is represented by the letter S, measures the spread of a data distribution relative to the mean. In other words, this tells us how dispersed and scattered the data are away from the mean. Let's refer to the example down below so you have a better understanding of what the standard deviation represents. So in this example over here, you've got a distribution with a small standard deviation. The reason why it's small is because you can see that it's a lot more narrow, therefore the values are more compact and similar to the actual mean value. In contrast, this particular distribution has a larger standard deviation, and what that means is that the values are less clustered around the mean and are more dispersed. And because you've got values that are more scattered away, therefore that has a larger spread, a larger standard deviation. Furthermore, just like the range, the standard deviation is only reliable when you've got a symmetrical distribution and contains no outliers. Once it does contain an outlier, or once it is positively or negatively skewed, then we shouldn't really use the standard deviation or the range to calculate the spread. We should therefore use the interquartile range instead. In order for us to calculate the standard deviation, then we're going to need to apply the funky formula that you see on my screen over here. However, for the purposes of this course, we don't need to actually learn how to calculate this by hand, and we're going to do this by using the CAS calculator. So what I'm going to do now is I want to show you how do we find out all the summary statistics using the CAS calculator. So with our CAS calculator, we're able to find out what is the mean, standard deviation, the lower or first quartile, the upper quartile, the median, the minimum, and the maximum all at once on the screen. Unfortunately, the calculator won't tell you directly what the interquartile range is, the range or the mode, but you could easily work what that is once you know the following information. Before I go through this example, it's really important that you familiarize with the symbols that are used to represent each of the following measures. In this example that I'll be going through, please grab out your CAS calculator and see if you can follow along so that you can get the exact same information that I'll be obtaining. In order to get the summary statistics for this dataset, we're going to need to create our spreadsheet first. So the way that we do that is by clicking on this green icon over here under the main screen, and therefore it will take you to this page. Once you got to that page, we're going to then name the variable in column A. So in this case, the question is talking about rainfall. So I'm going to be putting the rainfall over here, and then I'm going to put all the other values under that column down over here. Once you've completed doing that, you're going to click onto the main home screen button, and then you're going to click on the calculate icon over here. Once you've done that, then I'm going to need you to press on to the menu button found on the calculator, then select statistics, stat calculations, one variable statistics, and then hit the OK button. If you've done that, then the window that should pop up would look something similar to this over here. Then you're going to need to select the variable that you've named for that column. So I've named it rainfall, so I'm going to select rainfall. And therefore, you're going to get a window that pops up with all the summary statistics. And again, as I said earlier on, it's important that you're familiar with what each of these symbols represent. So in this case, this represents my mean, this represents my standard deviation, and if you scroll down, you can find out what is the minimum, the maximum, the low quartile, and the upper quartile as well. So to therefore answer this question, and if you were to scroll all the way down, then you should get these answers over here. In terms of the IQR, you can find that by going Q3 minus Q1, and the range can be found by going the maximum value minus the minimum value. What I'd like you to do now is I'd like you to please answer questions from exercise 2G to get further practice using both by hand as well as a CAS calculator to find the summary statistics. This is the end of the video. Thank you guys for watching, and I'll see you guys again in the next one. Bye.